Welcome, I'm Megan Ehlers. I'm a marine science teacher over at Sarasota High School, and I also run the Carefree Learner program. So this boat that we're on right now was built by Sarasota High School students in 1978, and now we mostly take out Sarasota High School marine science students, and every 7th grade student in Sarasota County Schools is able to go out in this boat for free. So what we're going to be doing today is basically looking at the physical and the abiotic and living biotic factors in Sarasota Bay in this estuary. So if you look around right now, you can see that we're kind of surrounded with land, creating some protection. And outside the pass, kind of over to the west, is the Gulf of Mexico. So an estuary is an area where it's partially protected by land that has influences of salt and brackish water. So right next to Selby Botanical Gardens, Hudson Bay is one of those areas where fresh water enters Sarasota Bay. And if you can't really see down to the bottom, but it's only about 5 or 6 feet deep, and if you were to snorkel down there, what you would see is lots of seagrass that's covering at the bottom as patches, which is very similar to the grass that you have in your lawn. So it's a true plant, it has root stems and leaves, and it creates a great habitat or a place where organisms live for this species that we have here. So Sarasota Bay, we can describe it as a protected area with lots of biodiversity, lots of different species, and it also makes it a great nursery area for species that live their entire lives in Sarasota Bay and for some that come out from the Gulf of Mexico. So the next thing that we're going to be doing is we're going to be pulling a large otter trawl net to do a collection. And that's going to go along the bottom of the bay, collecting organisms but not disturbing the seagrass bed. This is our captain, Randall Patterson. He's also one of the educators on board. He has a long career in marine science education. And what he's doing is deploying the otter trawl net. So this large net, like I said, is going to go along the bottom of Sarasota Bay, and it's going to collect organisms in our seagrass bed. There's something called a tickler, which is a chain that's going to drop down to the bottom of Sarasota Bay. And remember that Sarasota Bay is only 5 or 6 feet deep, depending on the tide level. So even though we just deployed this net, it's not going to be going along the bottom and ripping up the seagrass bed itself. And in order to pull an otter trawl net in Sarasota Bay and do collections, you have to have a permit. We have an educational permit through the state of Florida. Anything that we collect has to be put back into the bay within 30 days. So Sarasota High School marine science students come out here every other week, and we do collections to bring back to the classroom. And there's also limits on the type of species that we can take back with us. So even though we might be able to take a smaller grouper for observation, even if the grouper was of size where it would be normally, if you were normally fishing for it, edible, that's not permitted because of the way it was caught. Aquarium right now are a lot of the things that were collected in Sarasota Bay. So the first thing I'm going to point out is the turtle grass. So remember that I said that if you were to dive down into Sarasota Bay, it's shallow, sunlight penetrates down to the bottom, and what we find are patches of seagrass. And this is one of the dominant species, turtle grass. And it grows like patches in your lawns. It's going to help provide habitat, places for organisms to hide, and it's also an important nursery area. So if you were to live down in the seagrass beds, you'd be less affected by tides or currents, It's a great place to lay eggs, so there's protection there, not only from predators, like I said, just wave action in general. And we're just going to look at some of the stuff that we caught. First, I just want to point out some other primary producers. So you probably already know plants photosynthesize. Again, true stems and leaves. But this is sargassum. This is a type of macroalgae or seaweed. And it comes in different colors, brown, red. We have some green in here, and it also photosynthesizes. But unlike a true plant that has a vascular system, these guys get everything in and out with diffusion. And also a really great hiding place. So one of the organisms that's going to feed on seagrass and algae is the sea urchin. So this is the purple sea urchin, very common here in Sarasota Bay, and it's related to sea stars. You can see that it has the radial symmetry. The spikes are for defense, but they wouldn't hurt you unless you were to step on it very hard. That's one of their adaptations. So that's, again, something to protect them from predation. And then if you look at the bottom, that's the mouth. So the sea urchins use teeth to kind of scrape algae off of rocks, and if there's a dead fish, they'll scrape that as well. And you can kind of see that the spines of the sea urchin are moving, but the spines are just a defensive adaptation. How they actually move around is through tube feet. So if we look in the water at these guys, you'll see hundreds and hundreds of clear tubes coming out, and they have a suction that's part of their water vascular system. So that's how they move around. So like I said, they're related to sea stars. They're echinoderms. And what they're going to feed on is going to be the seaweed and the seagrass. And they're an invertebrate, which means that they don't have a backbone. And to continue on with invertebrates, this is a scallop, and hopefully we can get it to open. If it does, we'll see hundreds of what look like blue eyes. And so they're a mollusk, they're related to clams, but they're one of the only ones that actually can swim. So they'll move their shell to suck in water and go to new places. So right now, Sarasota Bay Estuary Program and Sarasota Baywatch are seeding Sarasota Bay with another type of bivalve. They used to do scallops, but now they're doing clams and oysters. And what these guys do is they filter feed. So they're going to take in nutrients and algae and make the water more clear. And the more clear the water is, the more seagrass can grow, and the increase in biodiversity, the more species it can have. All right, we'll see if we can get this guy to open up in my hand. Sometimes if they're in the air. Not doing it. All right, so the next animal I'm going to talk about is the stone crab, which is a very, very tasty member. You may have had stone crab claws before. It's actually a very sustainable fishery because when you capture the stone crab, you just take the claw and it can live and grow the claw back when it molts. So this is still a juvenile stone crab, but this is when they're very, very tiny. See this little guy? And how dark and almost purplish the stone crab is at this stage. So usually, as they're juveniles, they're going to be darker in color, brownish and greenish, so they can hide from predators. So remember, Sarasota Bay is a really important nursery area, so that's why we find a lot of these species. And I'll take this guy out. And it's too young for me to determine the sex of it. But you can see those really distinctive claws with the dark ends. So one of the adaptations that this guy has, this is a sea hare, and you might be able to see some purple coming out of it, is it's going to release a purple cloud to kind of confuse predators. So this is also a mollusk. Think of it as kind of a sea slug. And you can see the body is brownish to blend in with the green and the browns in Sarasota Bay. And then the hair-like parts on it kind of look like seaweed. Looks very unexciting. This is a sea squirt, aptly named. And it's actually a very, very advanced invertebrate. So everything we've looked at so far doesn't have a backbone. It's an invertebrate. This is actually in Urochordata, and humans are chordates. They have a backbone. So this animal, even though it has no eyes, it's sessile, so it doesn't move. It actually is more closely related to humans than anything else that we've looked at, and that the fish that we're going to look at. Well, as far as invertebrates, I should say. All right. So this is a pinfish, and this is going to be one of the most common species that we have here in Sarasota Bay. So this is a favorite food of dolphin and a lot of other fish, but a lot of fish can't actually eat it because of the spines that are on the dorsal fin. So that's one of their adaptations, and you'll see birds grab the pinfish, flip them around, and eat them head first. So the reason they do that is if you were to grab this guy from behind, it would get caught in your throat and you'd have to spit it out. So what birds do is turn them around, eat them head first, the top of their throat hits the dorsal fin, and it goes right into the gullet. So that's a pinfish. All right, and this guy right here is a striped burrfish. So its adaptations to avoid predation are these spines, and it can actually blow up like a balloon, but we're not going to do that. We don't want to stress it out. But if you look very closely at the mouth, there are teeth, and those teeth can actually, and those teeth can actually crack some invertebrates, shells, and things like that. All right, we'll put this guy in. This is a sea robin. And as far as adaptations go, this has one of the most unique ones that we'll see. You can see what looks like little legs. These are actually modified fin rays. So through evolution, what was once part of the fin became these little legs, and they actually use those to kind of crawl around on the sand. So they're benthic. If you were to look at this guy from above, he'd blend in because he's brown. And then on the bottom, he's white. So if he was swimming above the water, he would blend in with the sun. That's counter shading. That's another adaptation. And then if you look over, you can see the fins look like wings.